In this tutorial, we are going to take a look at how to create and invoke tasks using Celery. Celery is an asynchronous distributed task queue based on distributed message passing. It is focused on real-time operation, which supports scheduling as well. So the execution units called tasks are executed concurrently on a single or more worker servers using multiprocessing. So there are certain assumptions and requirements to get started. So I assume your environment has Python installed in it, Celery and RabbitMQ server. So in this tutorial, I'm gonna use RabbitMQ server as a broker. So let's get started. I'm gonna create a Celery instance and then a simple tasks. So let's define a project, and already I have a project defined so that we can get to the basics directly. So the content of the project should be so you should have a Celery class, a class for tasks, and then init. So init says it's just a project in Python, and then let's get into celery.py. Okay, so I'm importing Celery from the module Celery, and then I'm creating a Celery object. So the first parameters gives a name of the current module. The second one, it's a broker. Third one is a result backend. I'm using RabbitMQ server for the tutorial purpose. If you want, you can change to Redis or MongoDB or anything as per your wish. And then the last parameter is include. It gives a list of modules to import when the worker starts. And these are optional configuration parameters. If you want, you can set it. There are a lot of configuration parameters for you to play around with. And then there is a main module. So this is a simple Celery class. Now we can talk about tasks. So I'm importing Celery from the Celery instance which we have defined just now, and then I'm annotating the function method with celery.task to intimate that this is a task object. So I have defined three basic tasks: add, multiply, and xsum. Add just takes in two parameters and returns a sum of two numbers. Multiply takes two parameters and returns a multiplication of two numbers. Xsum takes in a list of numbers and then returns a sum of numbers. Okay, so now we have defined a Celery instance and then a simple task. Now let's start the worker node. Okay, Celery worker. Make sure your project is accessible from here. Yeah, so I'm just outside the project and now I'm invoking the worker node. So you need to specify which project your app resides. Okay, so I'm connected to localhost because my RabbitMQ server is there, and then by default Celery creates a queue called Celery for every worker which you invoke. If you want, you can add additional queues while invoking the worker node, but for the tutorial purpose I'm not using those options. So now the worker node is started. Let's try to invoke the task. So from proj.tasks import all the tasks which we need. Okay, now it is as simple as yeah. So this is a simple way to invoke a task. So but this is going to be a synchronous call, so let's make it more flexible. So this is a asynchronous call, and if at all you have a result backend configured, then what you can do, yeah, so this is the way it goes. So if you append either delay or I guess it's apply async. Yeah, so delay is just a shortcut for apply async. So but there are also other parameters which you can pass. Let's say you want to you wish to add a countdown to your task. It should trigger sorry, before that, so you can see the log entries for all the tasks which have been invoked to the worker node. So let's say I want to invoke this task after 5 seconds, so I can pass in like this. You won't see, still the task is yet to be executed. Now after 5 seconds the task is executed, so then you get the result. Sometimes you may pass the signature of a task invocation to another process. So Celery provides a way called subtask for this purpose. A subtask wraps the arguments and execution options of a single task invocation in a way such that it can be passed to functions or even serialized and sent across the wire. So let's say you want to add a task along with countdown parameter of 10. Okay, sorry for the typo. Okay, sorry for the typo. Okay, I have invoked a new Python shell. So from proj.task mul comma exam. Okay, so this is a way to invoke a subtask. So subtask won't be invoked right away. So you need to save the subtask in some object and then pass the subtask to invoke the task. So let's say I define a subtask like this. By the way, yes is a shortcut for subtask. Now let's say I call the subtask now. So this is a way you invoke a subtask. So first I define a subtask here and then I invoke the subtask over here and then fetch the return value in an object and then I get the result back. So next I just went over a few command line options like countdown. There is something called ETA, and there is something called async. Queue. You can pass in queue along with, let's say, as I was telling, you can pass in a queue parameter when you invoke a worker. So let's say you want to restrict certain tasks to only a particular node. So then what you can do, let's say there is a queue called Q1. You can invoke it like this, assuming that some worker node is listening to a queue called Q1. So this task will be sent to that queue. So there are a lot of options available with Celery. Now let's get into the primitives. So the first primitive is group. It calls a list of tasks in parallel and returns a special result instance that lets you inspect the results as a group and retrieve return values in order. So let's first import group. Okay. So add subtask of I comma I. for I in x range of 10. So what this task does is that for every integer from 0 to 10, it creates a subtask which adds its own value and then returns the result as a group. So it's as simple as that. It is very fast, lightning fast. So the next primitive is chain. Tasks can be linked together so that after one task returns, the other is called. In a real world application, this is very much feasible as there will be a lot of dependencies among tasks. So let's check out a small example using chain. So what this task does, it first calls a add task 4, 4, the return will be 8, and then the 8 is passed as a second parameter to multiply. Yeah, so this is how you use a chain. Now the last parameter, the last primitive is chord. A chord is a group with a callback. So let's say you want to invoke certain tasks, and then once you fetch the result from all the tasks, and then you want to pass those results into some other tasks. So a simple example would be, I'm using the same example which I used above for group. Okay, so what this task does is that first this is the same as the one which we have defined earlier. So this result, this returns a list of numbers exactly the same as we did here. So all this list is passed to this second task. Oh, sorry, I didn't import chord. See how these primitives makes our life very much easier. So that's it from us. Hope the tutorial was very helpful to you to get started with Celery. Thanks one and all.